Hello, everyone. How's everybody doing today? I just came back from Argentina. I'm back in Germany. I left my son Hans behind. He's coming in about a month, maybe, around there. And I'm going to be using a new computer today. You know, I've had some sound problems, some video problem here and there. Please let me know in the comments section if there's some kind of problem, okay, with the sound or with um, uh, the video. Okay. Um, just want to announce one more time, reminder to everyone that we're going to have the seventh conference, the seventh Rational Physics Conference in Borås, Sweden. And if you don't know where Borås is, I mean, everybody knows where Borås is, right? It's somewhere between Stockholm and Denmark, somewhere in between there. You'll see it on the map, and hopefully we have some good beer to enjoy over there, like we did in Buenos Aires. We had a good time in Buenos Aires. Anyways, it's going to be anywhere between, I think it's June 6th to the 9th. That's like a Thursday to a Sunday. So if you plan to attend, please sign up. And you can sign up through Facebook. You can also send me an email or whatever to bill@youstupidrelativist.com, and we'll sign you up if you plan to go, if you plan to attend. Okay, so keep that in mind. That's going to be mid-year. Okay. And what else do I have to say? Well, that's about it. While I was in Buenos Aires, I came across an article that popped up in the newspaper over there. And it had to do with Harvard professors. Harvard professors who, you know, respectable people, obviously. And these people analyzed a little rock that came flying into our solar system. They say it's interstellar, comes from some other star. And the article that they're going to be publishing, this article, by the way, this article states, right, that this little device is made by some kind of intelligence. It's a what is called a light sail. And let me give you an idea what a light sail is, because I researched this some time ago. Light sail, imagine a little box, right? Maybe a couple kilograms at most. And it's a little sailboat. The sail is the size of the country of Turkey. Okay? So you have this enormous sail, special sail, but enormous sail, carrying a little box, maybe 1 or 2 kilograms. I think the number was 5 kilograms, but don't quote me on that. Supposedly, the photon balls from the sun, push this, known as a light sail, it's a sailboat, right? Pushes this sail forward and can push it at 1/10 of the speed of light in the best of cases. In other words, 300,000 kilometers per second, that's light. This would travel somewhere around 30,000 kilometers per second to the nearest star system. Okay, and that's the fastest thing that these people have devised. They say it's still being tested, by the way, but this is their plan, that maybe a light sail would be the way to travel to the stars. And what these guys did here, they wrote a paper, and here's the paper. Well, first, let me show you the article. This article, I looked it up. I had it in Spanish first, so I looked it up in English, and this is what it looks like. It says, mysterious interstellar object floating in space might be alien, say Harvard researchers. Now, this comes from on the top. Okay, we're talking about Harvard here. Okay. And these folks are saying that, this little stone that you see there, it looks like a rock, just like a slate. It's a flattened out type of rock. Looks more like and this is not a real life picture. This is just a drawing of what it might look like. They haven't really seen it very well. But they think that it looks something like this, like a thin piece of rock floating through space. And they say that these authors from Harvard say that this might be one of these light sails that some other civilization sent to us. Now, this comes from Harvard. That's important to note. And here's the article. Let me show you the article here. That's the one they're going to be publishing. It's going to be published in the Astrophysical Journal Letters. So here we have a lot of authority, a lot of respectability in this. We have not only the Astrophysical Journal Letters, but we have also people from Harvard publishing this. And these people are saying, they think it's interstellar origin, no problem there. But then the last line says, our general results apply to any light probes, they're referring to the light sail, right? Designed for interstellar travel, designed. In other words, some civilization sent us this little stone, okay? That's the idea. And, this comes from, especially this fellow. His name is Abraham or Avi Loeb. Okay, he's an Israeli-American theoretical physicist. Okay, and he works in cosmology, astrophysics at Harvard, and he's got quite a lot of authority behind him. He serves as the chair of the Harvard Astronomy Department, chair of the advisory committee on the Breakthrough Starshot Project. He's director of Harvard's Black Hole Initiative. He's got a lot of titles, and so his word is like gold. Okay, it's very important influence in the world of publishing and in the world of he's probably a peer reviewer for all I know, but he's an influential person. And so he writes that this might be a light sail coming from another civilization. And now he was criticized by his by many peers, and you can see the smirk on his face. Alien ship might be among us. And here you see just the address there. It says criticism from peers. Grumbling and criticism from peers. People are a little upset at him that he decided to go ahead and publish this article, knowing that it's nonsense, 120% nonsense. So, he decided to publish it, and apparently this journal is going to publish it, and his peers are a little upset about that because it makes them look bad, because none of them really believe that this is an alien ship, and they don't believe that he believes it either. So you wonder why he would go, out of his way to publish an article in which he claims that this stone could be a light sail. And when you do a little research on him, you find out that he is in charge of the light sail program, and he also is involved in SETI type organizations where they try to contact or listen in on communication coming from some other planet. And so it's all related. He's in charge of these programs, and he said, well, now that we have this stone coming in here, it could be a light sail, it could be from a civilization. It's like, the guy's putting too much interest in this, knowing that it's false, completely false. So the question is, why would they publish a paper like that? I mean, here I am. I've tried sending papers to Science, to Nature, and I get these little notes back saying, editorial space is very limited. Like we have to fight for it. And here you're trying to publish a theory that is different than the establishment theory, and they're not going to publish it. They just send it back saying, sorry, go somewhere else. And here this guy publishes nonsense, and there is room, editorial space for what he's got to publish. And so it kind of makes you wonder about the publishing world, how it really works, right? This guy has all the doors open, and of course, anyone who criticizes the establishment, he's going to have a hard time publishing, no doubt about it, no matter how good his theory is, especially if it violates the existing theories. So that's how the publishing world is set up these days. Anyways, he was able to publish this, or he's going to be, I don't think it's published yet, but it's already up there, so you can look at the article in its present form, and he's probably going to publish it. They're probably going to publish it. Now, sometime back, I looked at this whole program of the light sail to see if there's any possibility. See, I used to believe, like most people, or a lot of people at least out there, that, someday we would go to the stars. We would go first to the planets, terraform them. I was a Sagan follower. One of the reasons I left Carl Sagan was because eventually I figured out that there's no way, no possible way that we're getting out of here, out of the solar system. And why? I looked at this program and I started finding, what are we doing to see if we can get out of the planet? Are we going to Mars? Are we going to the moon? Are we going to set up some kind of torus that flies in space and we just live in these toruses forever and ever, reproducing, doing some agriculture, all in space? Are we going to go with a torus, maybe flying to another star system, maybe through some intergenerational mechanism where, we don't get there, but our great-grandsons get there, that kind of thing? We can even travel. We don't have to travel at the speed of light for that. All you have to do is just be in the torus, flying, spinning around, flying, and, generation after generation after generation, all being born and bred in the torus, and we eventually arrive at some other star system. Is this feasible? Is this even possible? Are we dreaming here? What is all this about? And so I started looking at the program, especially that NASA had. NASA had an official program, and it was run by this guy, Mark Mills. And he was in this, what is known as the breakthrough propulsion physics. And he eventually quit, or I guess they closed it down. They didn't want to spend any more money on it. And he concluded essentially that there was no possibility for the time being to travel interstellarly to another star, in other words, right? There was no possibility. So he created a new foundation. He went private, non-profitable organization. He founded. This is the Tau Zero organization, and you can see some of the things that they're looking at there, how they're going to get there, some of the destinations they have in mind. They talk about how they plan to get to another star system, essentially. So you can look them up and, in their website, and even contribute if you really believe in all this, money or whatever. And these people think they're going to get to, or, they're starting. And they have this dream that someday humans will reach the stars. And so they're preparing the groundwork for all that to happen someday, okay? And there was but here there's a book written about Mark Millis, among others. They talk about interstellar travel in general, colonization, that kind of thing. And this is what they say about Mark Mills in that book. It's called Beyond the Bermuda Triangle. And I'll just go through the underlying parts there. Faster than light travel remains speculation. That's how Mark Mills can conclude what he concluded after being in this breakthrough program, NASA breakthrough program. I think it was for 10 years, and that's all it lasted. Finally, NASA closed it down. He came to the conclusion that it's impossible. But they harbored the possibility that maybe using general relativity, we can get to the stars. Not really by traveling faster than light, because special relativity prohibits that. But maybe if space-time gives us a boost, like if space-time expands and we can hitch a ride on this space-time expansion, maybe we can reach the stars. We can travel, I guess faster than light, or, you can even do it through a wormhole to another universe, to another star system. There's so many things that general relativity has provided for us to beat the speed of light, that it holds this hope for people. People have this hope that maybe since we don't know everything, that maybe someday we can't travel faster than light. Some even speculate that we can. But for those who can't, they say, well, that doesn't limit us anyways, because we can still travel, with an Alcubierre type mechanism where you push against space-time. Right? Or space-time itself pushes our ship forward, or we go through a wormhole. There are all these other possibilities. And but meanwhile, this guy Mark Mills, he concluded warp drive remains a dream, and that's why the program was closed down finally, because they realized that there's no way right now to go at warp speed. Okay, which is really faster than light. It's this Hollywood-esque type thing, where you have the Enterprise just travels faster than light. You think you're already there. All you have to do is just dream it. That kind of thing. We all would love it. I mean, I love I love fiction. Believe me, I watch it. It's not that I have something against fiction. I have no problem with fiction. But I think we should get our feet back on the ground and say, well, that's Hollywood, but let's look at reality. Reality is we're not getting out of the planet. And you say, well, Bill, you're a little pessimistic, aren't you? You're a little negative there, right? You're giving us no hope. Yeah, I don't want to give you hope. And yes, I try not to give you hope, but I'm not pessimistic. It's known as realistic. Titanic is sinking. You can be optimistic, but your optimism is misplaced, okay? The reality is something else. Like you're falling from an airplane without a parachute, you can be very optimistic, right? It's not a question of being optimistic or pessimistic. You got to be realistic, right? That's the issue. And regarding interstellar travel, let me say it now, and I'll just give you my opinion. Obviously, different people have different opinions, and I'm going to justify it in a minute, okay? But I'll just give you the bottom line. We are the last humans on Earth. We are the last humans on Earth. If you believe that you're going to live to the age of 60, 70, you're going to get Social Security, all I can tell you is you're not going to make it. There's no possibility. I think we die here. Now, I'll clarify, I'm a lousy astrologer. My predictions are very lousy. I put more emphasis on science. I like to do science. I don't like to do predictions, but I'm a lousy astrologer. But my 5 cents worth is we are the last generation of humans on Earth. Maybe we have 20, 30 years at most to go. That's what I think. And I'm not talking about myself. I'm talking about really the new generation. I got three boys, right? And they're in the ages of, 27 to 40. And, I think they've already seen the light after listening to me, and they think it's going to go down. And I do have a theory for that. It's got to do with the mass extinctions that occurred in the past. And I'm saying they all occurred for the same reason. No asteroids, no volcanic activity, no, supernovas, none of that stuff. They all died for the same reason. It's the only reason, the only mechanism Mother Nature uses to kill species massively, massively. Different than background extinction, by the way. But massively, the reason mass extinctions occur is because of food, only because of food. Food is the mechanism Mother Nature uses to kill massively. The inversion of the ecological pyramid at the end of a cycle, and that is a predictable event. And that's a long story. I'm not going to get into all that. And I'm saying the same thing's going to happen to humans. Humans cannot avoid the food problem. There's no way humans have a solution for the food problem. Once the economy, the global economy collapses, that's it for food. Nobody produces food or delivers it to the city. And again, that's a long story. I'm not going to get into that. What I want to say is, because I want to concentrate on this interstellar travel, I'm saying it's impossible even if we don't go extinct, okay? Even if we don't go extinct, it's impossible to travel, okay? That's what I'm going to cover today. That's what I want to cover. Let's see. We had some questions there. Plans for rich to survive. Some of them will survive. Yeah, I don't think so. They won't survive. In fact, the rich are the first that will go. It's the other way around, Christy. Let me tell you why. It's a long story again, but I'll just try to summarize it here. I'll just say the following. The reason the rich will not survive, the rich depend on others, okay? And once money is no more, and that's the reason we're going to die, because money will be no more. Money will cease to be. And I know we got people like Dave and people like Shamu, and they don't like me saying this. They criticize me, and we fight a lot over these subjects, okay? And we're probably going to do a lot of that and bore us, for sure, around some beers. But this is the issue. The issue is the rich will not survive, like no lost tribe will survive. People say, oh, but the lost tribes. No, neither the lost tribes, neither the rich will survive. The lost tribes will be the first to go, and so will the rich. And the reason they will be the first to go is they rely on other people. When money is no more, there's no allegiance. There's no allegiance. The servant does not have to serve the master anymore. Okay, and so it's the rich have no protection. What are they going to give them? Money? Are you going to bribe them with money? You're not going to be a servant once there's no classes. Okay, that's the issue. Anyways, getting back to interstellar travel, that's what I want to deal with today. And the issue is as follows. I've got a couple of videos there. One is known as the Pioneer, and I analyzed the Pioneer probes. Turns out that the Pioneers, there's a Pioneer 10 and Pioneer 11, they were sent out in the 70s, okay? They were sent out, and today they're just going right outside, in fact, sometime back already, but they've gone out of the solar system, okay? And just before they went out, or when they lost contact with these probes, they realized that the probes were decelerating towards the sun. And it was known as the Pioneer anomaly problem. These pioneers were slowing down as they were going out of the system. And what happens? They try to figure out what was causing that, what physical entity was causing it. Was there a new law, mathematical law on how gravity works? Was the sun somehow pulling back on them? What was going on? And they tried to figure out. Well, for many years, over 10 years, they couldn't figure out what was going on with the probes. And they finally came up and they said, look, this is what the people who handled the probes, the people who were part of the project, the managers of the project, they finally were the ones who solved the problem, right? Quotations there. And this is Turishev, one of the guys who was in charge of it. He says, thermal radiation was a leading candidate. If only 60 watts more heat had radiated off the back of each probe, conservation of momentum would cause them to recoil just enough to explain the anomaly. We hope to establish as precisely as possible how much heat these spacecraft really were shedding unevenly. what was their argument? Their argument was that the spacecraft were irregular in shape. And so they were losing heat in the direction of travel, and this was slowing them down. This is what they concluded after many years of study. And the people who concluded were the people who were running the program, okay? And so, you know, a lot of people were still unsatisfied with that, but that's the final word today. The final word is that the probe were simply losing heat. Turns out that both of them were losing heat, you know. So both 10 and 11, they went in different directions, but they were both losing heat because of their irregular shape, and that's the only thing they concluded. But it turns out that, you know, there were other probes, and here you see them. You have the Galileo, the Ulysses, and the Cassini probe. Galileo went to Jupiter, Ulysses went to the Sun, and Cassini went to Saturn. And these probes suffered the same type of problems. Okay, they suffered the same type, similar. They were measured to slow down. And the question is, all these probes have the same problem? All of them decelerate for some reason, for some unknown reason. They all have heat in front of them. And so, again, a lot of people are still not satisfied that there's a conclusion to this problem. But, you know, there is a final word, and that's the one these people say. It's the heat in front of the probe. That's the answer they've got today. Okay, but I think there's something more profound here to look at, and that's when we come in with a rope model of light. If all the atoms in the universe are interconnected, we have to, I mean, if we concede that as a starting hypothesis, as an assumption, then now we have to look at what effect that might have on these types of problems. We have to analyze a problem from that point of view, if the rope model has any merit whatsoever. Okay, that's the way you got to look at this. Otherwise, you know, you got to reject. If we follow Karl Popper, we have to reject the assumption. We have to, or the theory, or whatever. You know, you have to reject that because you say, you know, it falsifies your assumption, falsifies your theory, that kind of thing. Okay. Okay, so what is the issue? Here's how a galaxy works. Okay, galaxy is like a spider web. All the stars are interconnected. Okay, so if you put a spider web there, it gives you an idea of why a galaxy rotates like a carousel. Everything is interconnected. Okay, that's what the rope model says. That's what it proposes. Here's if we superimpose upon that the magnetic field of the galaxy, it maintains the integrity. Okay, we have the threads just sweeping around the galaxy, maintaining the integrity of the galaxy, together with the fact that all stars are interconnected. Okay, so that's why the galaxies kind of rotate as a wheel, you could say, you know, as a bicycle wheel. Okay, spokes keep everything tight. The outside of the wheel goes just as fast, or faster, really, than the inside of the wheel, just to keep in pace. Okay, and you know, if you got to look at it as something like this. These are the stars. That's how you should look at this. All stars are interconnected. And each one of those little lines that you see there, you have to think of those as coaxials, okay? Because a star, you know, it's got gazillions of atoms. Each atom is connected to the atoms of the other star. But the farther away you get from the star, you know, all the ropes come together. And they act as one. So they act as a single coaxial. So even though those lines are kind of thin, you got to think of it more or less as if it were a coaxial of gazillions of ropes. Okay? And so what does it look like? Well, it's going to look like something like this. Let's see if I got it here. Here's just showing how the ropes would pull, for example, a comet towards it, so that you also get an idea. Okay, a comet coming into the solar system, as it approaches the sun, the ropes fan out. Okay, and that is the acceleration of gravity that you're seeing there. And of course, it's got to be exponential. Okay, as it gets closer to the sun, the ropes just fan out, and that's what's each one acts independently, and that is what's causing the acceleration of anything that approaches massive objects such as the sun in this case. Okay, so that's the notion that we have to keep in mind. But what does it mean? If you look at that last shot there, you can see that it forms like a beak, what I call the bird's beak, from the sun to the comet. Okay, if you look at the ropes, they form this bird's beak. And here I have another picture of that. Okay, here you'll see it. That's the bird's beak. Okay, and it's again, it's a square of the distance type of phenomenon. Okay, and if you go to the other side, like if you go to Proxima Centauri, you're going to go through this linear regime, the coaxial, and then on the other side you'll see Proxima Centauri. It's also got a bird's beak. Okay, understood? So we have the sun and its bird's beak. Okay, which is that region where Newtonian gravity works. Then you have a long linear region, which is the coaxial. Okay, I call it the linear regime. And at the other end, wherever another star is, it also has a bird's beak, coming in from every star in the universe. Okay, so that's how you have to imagine this under the rope model. Okay, or at least that's my proposal. Maybe someone more intelligent can probably come up with something better, but that's what I've come up with. I'm saying, you have a star. Okay, every atom in the sun, okay, is tied to every atom in the nearest star, which is Proxima Centauri. Okay, they have this bird's beak, all these ropes converging as they leave the solar system. Then there's this long region, at least between these two stars, where you have the linear region. And then again, you have, as you approach Proxima Centauri, you would have the bird's beak again. Okay, you have this exponential region. I'm saying Newtonian gravity only functions in that bird's beak, in the bird's beak area, where gravity is exponential, where the number of ropes kind of converges. But as you get to the linear region, you no longer have Newtonian gravity. That's my argument, okay? Yeah, none of this has to do whether you believe me or not. It's got to do with understanding what I'm proposing, okay? And I'm saying when you get into that linear region, you no longer have acceleration, okay? Now you're just drifting. And I've got a little picture here to show you. Looks more or less like this. This is the linear region. And this is what you would see. You're just being pulled you're just moving through threads. Here's Proxima on one side, the sun on the other. You go through the bird's beak. And here's the probe trying to get into the linear region. It's going to slow down as it gets in there. And then it's just going to drift. And here's the Enterprise doing the same thing. Once it gets into the linear region, it's going to slow down. And I'm saying this is what's causing the probes, the Pioneers, to slow down, the Cassini and all these others. And that's, again, the linear region where you're just traveling through the linear region there from one star to another. Okay, so it's the bird's beak will, as you approach the linear region, you slow down. And I'm saying that's what's causing the slowing down of the Pioneers. Okay, why is this important? Well, again, it's important because I'm trying to argue here that life cannot travel interstellarly. That's what I'm saying. And which again destroys the theory of these people, the paper they're writing, saying, oh, maybe this was a light sail from another planet. Even assuming they were joking, even assuming that their only purpose was to do a little commercial for their own projects or for their own careers. If we brush that aside, is there any possibility to travel interstellarly? And I'm saying there is no possibility whatsoever. And the reason is, again, you're going to get into this linear region, you're going to slow down. So, this warp speed thing that NASA was researching would be nice, which is great for Hollywood kind of stuff. Seeing, the Klingons visiting us and we visit them, never going to happen. It's nice in Hollywood, but it's not realistic. It's not that I'm a pessimist. It's that we have to be realistic. Is it possible? Is it possible? Under the rope model, It's not. It's not. And it's not because, again, you get into this linear region, you slow down, and it would take eons for you just to reach the nearest star. You would not be traveling at the speed of light, for sure. Whatever speed you're coming after the bird speed, that's the speed you're going to be traveling, unless you turn the boosters on and somehow get a little boost there. But even then, no way you can travel at warp speed, and especially through that bird speed. You cannot through the linear region. You cannot count. You cannot count on gravity pulling you, because that's another theory that came up, that maybe we can have a gravitational assist from destination somehow. The Klingons pull you in. One possibility, right? I mean, let's consider all possibilities. The Klingons pull you in somehow. That's impossible. That's impossible because, again, you go into a linear region. This is not a question of tying a rope to your little boat and pulling you over. It's the question of whether it's possible for gravity to pull you in from your destination. And I'm saying that in the linear region, gravity has no effect. You're just going to drift at whatever speed you came, plus whatever booster you can turn on your ship. That's it. And for sure, you're not going to travel at warp speed. And if you're talking about 4.3 light years to the nearest star, traveling at the speed of light, that's how far this thing is. It takes you 4.3 years to get there if you travel at the speed of light. You can imagine that at much slower speeds, the fastest we can travel is about 40,000 kilometers per hour. Per hour, not 300,000 kilometers per second, which is light. So if that's the fastest speed, and that's with all kinds of assists, we get assists from Venus. We send our probes through Venus, and then they give us this gravitational assist to go to Mars. They do this kind of stuff, and it works. As fast as we can travel, it's about 40,000 kilometers per hour. So we're very far away, and that's why Mark Millis, he dropped the ball. He said, look, for the time being, there's no possibility whatsoever. And I'm saying it will never happen. Extinction will happen much earlier than what these people are saying. And again, that's a separate story. I'll deal with that another day, and I'm sure some people will fight me on that one to the end for sure. But my point is that even assuming we don't become extinct, right, physically, it's like the guy falling from the airplane without a parachute. You got to be realistic. It's not a question of pessimism or optimism. You got to be realistic. And realistically, if the rope model has any validity, you cannot exit the solar system at warp speed. Forget about that. But you cannot even exit the solar system at any decent speed in which you can design a program and say, oh, we're going to go to the nearest star here. We're going to go to Proxima. It's just barely 4.3 light years away. And okay, we don't travel at the speed of light, but maybe a couple generations of, Taurus-like mechanisms where people are born there, and grandsons and great-grandsons are born there, and finally one generation makes it over there. Totally unreal. It's never going to happen. Not in my mind, for sure. And if you have a better idea, okay, fine. But that's my 5 cents worth on that. And so if that's the case, if we cannot travel to the nearest star, it means also that no one from another star can travel over here. And now we get into another discussion here. The discussion could be, well, they're more intelligent than us. They have these green antennas and so on, eyes popping out. They're much smarter than us. No way. Humans are the top intelligence in the universe. Let me repeat that. The highest intelligence in the entire universe is humans. And you say, well, how can you be sure of that? How do you know that? Okay. Let me tell you how I know that. Well, first we have to define intelligence, and no one has been very successful at that. I do define intelligence in my book. I also define it on my website, so you can go search it there. In the old Ye old, youstupidrelativist.com, you'll find it there in the interstellar travel. I define intelligence, and the issue is that, you know, every living entity has intelligence because the cell is already intelligent if we define intelligence as simply a central processing unit. Once you have a central processing unit, which a cell has, you know, a human cell, etc., it already can do things intelligently or in an organized manner. Okay, so intelligence is at the cell level already. Now there are different levels of intelligence, right? And you say, how can you be sure that yours is the highest intelligence? Well, let me give you a clue. If God himself, almighty, omniscient, comes here and explains to us something that we don't know, that, you know, something outrageous, something out of this world, we have the capability of understanding what God is telling us. We have the intelligence to understand it. Mother Nature has no more gifts to give us. We have the highest gift that Mother Nature can give us, and that is understanding. We can understand many things. Not only can we discover and research things, but we can understand if someone explains it to us. There is no higher intelligence than the one we have, humans. So if some other civilization developed in some other planet, at most it has the same intelligence, the same level of intelligence as we do. They might have more technology. Let's concede that for a second. It doesn't mean they have more intelligence, okay? The level, if they come here and explain to us, you know, how they built their ship, how they came, we're going to understand it. We have the intelligence to understand them. There is no magical intelligence out there, super intelligence, as they say. There is no such thing. We are the super intelligence. We are the maximum intelligence in the universe. And, you know, if there's another civilization out there, and there's very likely some other civilization out there, maybe at the same level as us, as far as development is concerned, you know, they've got the same problems we've got. And they're going to become extinct, like I say, in their own planet, and they'll never hear of us, and we'll never hear of them. They've done studies, and 20 light years in the vicinity, they haven't had any feedback. You know, nobody sent us electromagnetic signals. They're still listening, they still have their ears, but 20 light years in the radius, in the vicinity, we haven't found life so far, okay? And let me tell you what the problem is. Part of the problem, at least, is, you know, not only is there a question of, you know, do we find a planet similar to Earth that is blue, has water, has air, you know, all the nice goodies to create life? That's one issue. You know, that's already, as we can see in our own solar system, we're the only guys with life. All the others are just rocks with some gas around them, whatever, but no sign of life. And I don't think they'll ever find any life on any of the other planets or any of the other rocks in our system. But we won't find it in maybe in 20 light years around us, at least, because life is a very rare occurrence in the universe. That's my 10 cents worth. I think it's a very rare occurrence. It has to have special conditions to happen. And even if life develops, it doesn't mean it's going to reach the same level it's reached here on Earth. You might have some other types of animals, some other types of plants, because they developed in slightly different environments, maybe colder, maybe hotter, maybe more massive, gravity is greater, maybe gravity is less, you know. So it's similar to Earth, but not quite. Maybe it's farther away from its star, so it doesn't have the same heat. Maybe it's got the wrong tilt, or the wrong, or not wrong, but different tilt, different magnetic field, different amount of air. You know, there are many variables. And, you know, when you put all those variables together, maybe life is a very rare thing in the universe. But assuming there is some life out there, it's got to be very rare, and it's got to be, and you know, it has to develop similar to what happened here on Earth, I would think. You know, there's got to be this evolution where life progresses. But we could be staggered in time. You know, maybe these guys already died. They became extinct a long time ago, and now we come up, and now we're going to die. We're going to go extinct. Some other planet here develops life, and they say, oh, we're going to look around, see if we can find some life out there. Yeah, there was life on Earth, you know, billions of years ago, but we're gone now, and now some other civilization is out there. And so we have these, not only do we have the conditions, but we have staggering in time. And then even assuming, I mean, how long have we had electromagnetism? 400 years maybe, that we've been studying in earnest. You know, what is electricity? What is magnetism? Can we send, you know, information, etc.? I mean, maybe 19th century to our days, what is that, 200 years at most? That's all we've had. 200 years is nothing in the scheme of things of the universe. So even if we take our 200 years, that's it, and let's assume we go extinct, as I say, right? Then another civilization, maybe they're staggered by 100 years from us, they come up and they invent all the stuff we invented, and now they're going to go through the same rigmarole. You know, they're going to find, say, well, we're going to put our telescopes out there and see if we can find some life out there. We're dead. You know, they came 100 years too late for us to see them. So there's a time issue. And the window is so small, 200 years. That's nothing at the cosmic level. You know, in the scheme of things, in geological terms, it's a blink of an eye. That's what 200 years is. And so, you know, there's a lot of problems with finding life out there. Life is not abundant throughout the universe first. The conditions have to be just right. And then you have the issue of intelligence. You know, intelligence develops maybe, smart intelligence. In other words, intelligence tied with technology. Technology that can send and receive. You know, the window is so small that there's almost no chance whatsoever of ever discovering, you know, another civilization. Let alone sending something out there, a light sail, that will reach another planet. So no, people have to be more realistic. It's not that I'm pessimistic. I drink beer. I drink wine. I'm not pessimistic at all. I'm realistic. And so, you know, for these people, you know, the Harvard boys here to say, look, you know, we think it's a light sail when they know it's not. It's just propaganda. They're just running a commercial for their projects, for their careers. You know, and they're allowed to do that because they have all this authority. They have all these connections. They call the, you know, the guy at the magazine, at the journal, and they say, please publish my thing. You know, I'm so-and-so. Oh, yeah, sure, we'll publish you, you know. And so, you know, they publish these things knowing it's not true. And it's just, you know, you shouldn't be sidetracked by what they're doing there for their own personal interest. But I'm saying realistically, there is no chance of going to another planet, and there's no chance for another civilization to contact us. You know, it's not going to happen. And again, you know, all I can tell you is I've got a lot written on that subject, and I can't cover it here in just one, you know, little lecture here. But I'm saying is, if you look at the realistic part of the, is it possible really? You'll probably conclude, if you think long enough like I did, and believe me, I used to believe in this, you'll come to the same conclusion that I have, and it's never going to happen. Which means that all these projects that NASA have, European Space Agency, Japanese, Chinese, Russian space agencies, they have all these projects out there, they're worthless. They're just wasting their money. If they do it for military reasons, no problem. I can understand that. But if they're doing it to really colonize, like I say, you know, in my analysis, what are we going to do? Are we going to evacuate the Earth? Are we going to just go out there and do some research and look at another planet and say, oh, how beautiful, you know, we found Jupiter here and it's got all these rings and all these moons and all these gases. Is it just scientific research? Is that what it's for? Or is it to really colonize, you know, and live there? What are we doing all this space stuff for? If we have no chance of colonizing, if we have no chance of terraforming a planet like Mars, first because of the cost, and second because of the, you know, the engineering obstacles that are in our way, then what are we spending all this money for? What are we investing in that for? And again, the fact that Mark Mills, his program was shut off, and he had to create his own organization, his dream organization, just selling you a dream, saying, "Oh, someday we'll go out into space," gives you an idea that it's never going to happen. And I know we all would love to see the Klingons. We'd love to travel out there and say, "Oh, it'd be nice." It's not pessimism; it's realism. It's just unrealistic to think that we're ever going to go outside, the solar system. We're fine right here in this blue heaven. Believe me, this is as good as it gets. It's not going to get any better out there. Travel to the moon, you want to go, you got $1 billion, you want to take a spaceship and just go around for a week and say, "Oh, I've been out there in space, I've seen the moon," fine. I have no problem with that kind of tourism, right? Colonize and live in Mars. No, it's never going to happen. And again, I used to believe in all this stuff too. So I've changed my mind 180 degrees on that one. Anyways, that's my 50 cents worth on this issue. Don't put your hand in the fire for interstellar travel or communication even. Forget about interstellar travel. I'm saying we're never even going to contact another civilization, and they're never going to contact us in any way, shape, or form. We're never going to receive a message, what is it, a little letter in the bottle kind of thing, from what was it, Superman planet, I forgot the name, they sent the spaceship over here. Never going to happen. We die here on Earth without ever contacting another civilization. Partly because there's no money, but the technical obstacles are simply impossible. Okay, my 5 cents worth. We'll see you on Wednesday. Anyways, that's what I've got to say today. Bye bye.